Computer Science and Engineering Colloquia features accessible talks by leading computer scientists and computer engineers from across the region and around the world.
Welcome to this afternoon's colloquium. It's a great pleasure for me to introduce Professor Arpita Ghosh from Cornell. She's done a lot of really cool work at the intersection of game theory, algorithms, computer science, and beyond, and I will just let her tell us.
Thank you very much. Thanks very much, Anna, for introducing me and for having me here. And it's just been wonderful being here so far. Lots of very interesting conversations. I'm looking forward to the rest of my day here as well. So what I'm going to talk about today is incentives in online contribution and really thinking about a game-theoretic framework for incentives in online contribution. So of course, I hardly need to tell you guys where a lot of the stuff is happening, has happened about user contribution on the web. And users contribute on the web on lots and lots of sites. They contribute in citizen science projects. They contribute in crowdsourcing contests. They contribute user-generated content. So for example, if you think about it, there's really explicit contribution where users are explicitly creating something to contribute on the web. Wikipedia, YouTube, reviews, question-answer forums. Also online education, when you think about peer grading and peer learning on discussion forums, all of that is really user contribution at scale. There's also implicit contribution where users don't put in explicit effort into creating something new for contributing, but they do contribute the data from their online footprints, their search and browsing behavior, location, learning patterns, and so on. And all of this is contribution as well, even though it might not immediately strike you as contribution, because it leads to improved search, recommendations, and so on and so forth. So really, very broadly, although we won't get into detail on the second half at all, very broadly, when I speak about user contribution on the web, I want you to keep in mind both explicit and implicit user contribution. All of this is very nice, and all the pictures I showed you, all the systems I mentioned, they just seem to indicate that user contribution on the web is going great, which is true. But if you think about it, when users contribute on the web, they're not really automatons doing things. They have a choice. And really, the users who create all this value on the web via writing reviews or by citizen science or with their data are really economic agents. And what do I mean by economic agents? That term is used in a variety of contexts with different meanings. The sense in which I use the term economics agents is also a standard one, which is really actors who take decisions in a system. They have their own costs and benefits and preferences over outcomes. And if this is sounding all too monetary to you, I want to say that when you think about costs and benefits, the altruistic benefit from seeing someone benefit, someone else consuming what you create is a benefit. Things like disliking the fact that your data may be used against you is a privacy cost. So when I say costs and benefits, I don't mean X dollars and Y dollars. I really mean very broadly anything that can be thought of as a cost or a benefit. Okay? So the benefits could be plain old monetary, or they could be social psychological rewards, such as attention. People like getting attention. There's empirical evidence of this from studies of YouTube. People like status. It could be something like improved service quality. And your costs really are effort costs. When you create an answer and put it up on the web, it took you some work to write that answer. When you contribute to a citizen science project, maybe it took you 10 hours, and that is some cost. There could also be privacy costs. So for example, these may not be things you tangibly realize immediately, but you might incur some privacy cost when you contribute your data or when your data is collected, whether you're explicitly contributing or not. And anytime you have a system with economic agents, such as we do over here, the choices made by users determine the performance of the system. And these choices could be participation or effort. For example, you could agree to share your data or not. You could decide the quality of the content that you contribute on Amazon reviews. Do you write a good review, or do you write one of these lousy reviews, was great? Or do you write one of those long, nice reviews that says exactly what happened and so on? So you could be making choices simply about whether or not to participate at all. And conditional on participating in some other cases, you might be making choices about the quality or the quantity of your contribution. How many questions do you choose to answer? How many citizen science images do you choose to label, and so on. And the question that we're going to be interested in is given that users potentially make choices, and given that their choices determine the performance of each of these systems, how do you design good online contribution environments? And when you think about this question of designing online environments to incentivize contribution, there's at least two components to it, probably many, many, many more, but there's broadly at least two components to it. The first question is what drives contribution? What are the rewards and what are the costs? And why is it that people are doing this? The second question, which comes after perhaps you understand the first one, what are the rewards and what are the costs, is a question regarding how do you allocate these rewards that you've now understood people are working for attention or working for status or something. How do you allocate these rewards among self-interested users? And the answer to the first question, what drives contribution, is something that has been studied in social psychology theory via experimental empirical studies and so on and so forth. Understanding both at a high level what are the motivators that drive people's contribution, as well as understanding at a more nuanced level exactly how users value these various costs and benefits. And that's not what I'm going to talk about at all. That's not the work I've done either. What I'm going to talk about is the second aspect, which is once you've understood what these rewards are, how do you allocate them? And there are questions relating to economics and algorithms. And what we're going to be thinking about is a game-theoretic framework for incentive design. How many people here are rather familiar with what a game-theoretic framework might mean? OK, so there's lots of people who aren't. So why don't I just spell out what I mean by this? So here's very broadly, and this is not specific to user contribution alone. This is very broadly. What does the game-theoretic approach do? Here is a system. It's designed and induces the allocation of rewards. So for example, think about something like, say, a crowdsourcing contest. Like, perhaps most of you have heard of something like Innocentive or Topcoder or Kaggle, where you go submit solutions to some kind of programming contest and return for money if you have the best contest. Okay? So in the simple case, the question might be, does Topcoder decide to offer one first prize, or does it offer a prize to the top 3 best solutions or something like that? That's a specific case where the system design is the allocation of the prizes. What about when you don't have money? You have virtual points. So for example, Yahoo Answers had this scheme whereby the best answer to a question as decided by users or by the asker gets 10 points and everyone else gets 2 points. And for some reason, users like these points. Okay? They work for them. I don't understand these users, but they do. So that's, again, one of these cases where the system design specifies the allocation of rewards. And these are cases where the allocation of rewards is very explicitly specified. There are also more interesting things like attention. Now, if you buy into the fact that attention is a reward, and if you don't buy into the fact, don't look at me, there are papers that say attention is a reward and people work for attention. Specifically, they post more on YouTube when they're getting attention, less when they don't, and this is documented. Now think about, for example, YouTube. What order it displays videos in when a user visits a page is an aspect of system design that's really a reward allocation scheme. So it has some inference about quality, let's say. Let's forget about personalization for the time being. It makes some inferences about quality and decides to display things in some order. That's a reward allocation scheme. As a specific other example, if you think about a question-answer forum, I could decide to display the best answer only. I could decide to display the best 3 answers. I could decide to display all answers, and each of these corresponds to a different reward allocation scheme. So really, these are cases where the design of the site is inducing some kind of allocation of rewards. Okay? Is everyone clear about what I mean by reward allocation now? Self-interested users are making choices to maximize their payoff given the design of the system. So for example, they might just be deciding whether or not it's worth their while to participate, whether or not it's worth their while to contribute anything at all or not. They might be deciding, for example, do they bother to upload just cat videos, or do they bother to really put in effort and make nice videos for YouTube, and so on. It could also be about truthfully revealing information, and we're not going to talk about this much at all. Incentive design is all about aligning the user's incentives with the incentives of the system. So the user wants to maximize her payoff. The system wants the users to do something. The idea is to set up incentives for the users so that what the users do is what the system wants. And the reason this is not just one problem, is that there are differing reward types. So for example, social psychological rewards have very different properties in terms of whether they're large or small, whether they grow with the number of users in the system or not, than say monetary rewards. If you have $500 and 1,000 participants, you still have $500. If you have $500 and 10 participants, you still have $500. The constraints are different. The observability across applications are different. When you are rewarding someone, what are you rewarding them on the basis of? Presumably what they contribute. How well can you measure what they contribute? And this is why you have a whole family of different problems with different aspects. Okay, so where were we? We were saying that I'm going to talk to you about a game-theoretic framework for design. And by now, I think the previous slide was meant to tell you what does a game-theoretic framework look like in general. And I'm going to do this, but throughout, there's a higher level point that I want to make, and it's the following. It's that when you think about many of these online contribution environments, you might be thinking of them largely from the perspective, let's say, of HCI design or user interface design. You know, how many buttons do I put in? How many things do I show? And I want to make the point that formal analysis could have a nice give and take with the design of online contribution environments. And this give and take really comes across multiple disciplines. So first, of course, there's the give and take between theory and empirical and experimental research. And that's a point that's hardly new. Theory needs to draw from empirical research, and theory can in turn inform experimental and empirical research in terms of what are the right questions to be asking. I'm also going to make the point that there's potentially a huge give and take possible between game theory and interface design, which is that and we'll talk more about this, which is that the interface design informs what the parameters of the game are, and the game theoretic analysis can also inform what the design of interfaces might look like. And finally, there's also a give and take, and again, this is also not terribly new, between economic analysis and policy, and this also applies to the setting of online environments. So as I said, when you think about online contribution, there's explicit contribution and implicit contribution, and we're going to be interested in formal analysis of incentive design for both of these. We're not going to talk at all about the second half, not because I don't like it, but because we only have a little bit of time. We are going to talk largely about explicit contribution, which is contribution to user-generated content type of systems, by which I mean things like Amazon, Yelp reviews, crowdsourcing contests, citizen science, and so on. The second half, just to give you a very quick 1-minute summary, really thinks about what happens when you have privacy-sensitive users, users who have costs to privacy, and how do you compute on databases that are endogenous. What do I mean by that? If you think about, for example, you want to learn some statistic about a population, you're thinking about the fact that you have the information about the population. The question is one of computation. But what if the database itself is determined by the choices of users, who participates, and what do incentives do in terms of getting a representative sample? So we're not going to talk about that at all. So in terms of explicit contribution, what are the kinds of choices that users face? So remember, when we talked about a game-theoretic framework for design, we said that users are making choices in response to the incentives created by the system. What are the kinds of choices that users make? Users may make choices about participation, effort, and responsiveness. So for example, when you think about Amazon reviews, first of all, I make a choice about whether I'm going to write a review at all or not. Second, I might make a choice about whether to write a nice long review or whether to write a single crappy review. I might make a choice about how many reviews I write. There's also questions about responsiveness. Think about Piazza. How many of you guys are familiar with or use Piazza around here? 3 people. No, it's got to be more. Piazza. Yeah, I'm sure people use Piazza. So if you think about it, there's an issue of responsiveness over there, right? Do people respond quickly on Piazza, or do they take forever to show up and respond slowly? So these are all the kinds of choices that users can make. Let me talk briefly about effort, because we're going to talk at length about participation. So we'll get to participation shortly. Let me talk about effort. And when you think about effort, for example, you can think about quality in user-generated content. So what do formal models look like, and what are the kinds of questions they ask and answer? So one of the first models that was looking at quality in user-generated content from an economic or a formal perspective was some work by Jeff McKee-Mason at Michigan and some of his colleagues. And they were really talking about contributing user-generated content, contributing content on the web as a problem of provisioning of public goods. And if this is not familiar to you, you should really think about contributing to a common project that all of us benefit from. But each of us would prefer to not really contribute to it. And the kind of insight that this particular kind of model led to was to suggest things like you might want to make this not a public good. So for example, the classic example of what insight this provides is Glassdoor. Glassdoor is a company that allows people to read reviews about employers and how nice a place is to work at. But to make it, of course, they're not going to have any content if people can just go and read reviews, right? So what they do is they allow you to read a certain number of reviews for free, but after that, to read anything more, you have to contribute a review of your own. So essentially, what this says is that you are looking at content as a public good. That causes problems of under-provisioning. So you solve that problem by making it not a public good and making it excludable by saying you have to get something to give. You have to give something to get. A second and completely different perspective on user-generated content was something I worked on with Preston McAfee, who was then also at Yahoo Research. And that was thinking about contribution as a best response to private rewards. So if you think about people writing reviews or, let's say, comments on news articles as creating a public good, you can't really explain some things like why is there such a huge number of bad comments on websites. But if you think about it as a best response to private rewards, if you think about it as a best response to attention rewards, what was going on in these sites which were collecting a lot of junk is that they were essentially displaying content in the order in which it arrived, which basically meant that there wasn't any explicit reward for quality. So if there isn't a reward for quality, there's no incentive for quality. And so, of course, you are going to get a lot of junk. And once these sites changed to displaying things by some even imperfect measure of quality, much of this junk just disappeared overnight. So here is where a different model, thinking of it as a private best response, led to a completely different kind of insight than the public good type of model. And since then, there's been a whole bunch of work looking at various social psychological rewards, attention, status, virtual points, and all of those, and looking at how do you design mechanisms when those are the rewards that people are working for. You can ask questions about timing, when and how quickly to contribute in question-answer forums or collaborative problem solving and so on. And there's been a bunch of interesting work along those lines as well. There's work on information elicitation and so on and so forth. And all of these are really formal models for reasoning about how to incentivize contribution in online settings. So before getting to some very specific work which will give you a better idea of what I mean when I talk about this, I want to sort of make the connection between incentive design and how that can contribute to theory, and also how theory can contribute to incentive design. So a lot of the problems regarding online contribution have a very interesting feature, which is that if you want to get people to contribute high quality content, you want to reward them for quality. But the problem is that you really can't measure quality quite right. So quality could be imperfectly observable as in user-generated content. So you have users voting thumbs up, thumbs down on whether this was good content or not, but that's a noisy signal. That's not a perfect signal. And in some cases, the quality is just outright unobservable. An example of this is crowd work. So the whole idea behind crowd work, in not all of it, but a whole family of crowd work, relies on using the crowd in place of an expert. And the whole point is that, look, if you had enough experts to tell you the right answer, you wouldn't need the crowd in the first place. So this leads to something that's called unverifiable ground truth. You have workers providing you labels on images, and you don't know whether the labels they provided you are good or bad, because, hey, if you knew the labels of the images, you wouldn't be asking the workers to provide the labels in the first place. Now, how do you reward workers for actually doing a good job? So this is a case where you have completely unobservable quality, not just noisy signals as in the case of user-generated content, but just completely unobservable. And this leads to a whole range of interesting research problems in theoretical questions, really, regarding algorithms, incentives, and learning. So for example, there are questions about if you have a bunch of raters who are giving you ratings, a very basic question is how do you aggregate these into one rating? This is a basic problem that's very well known and very well understood until you get to the point where you don't know the qualities of the raters themselves. So you have labels from a bunch of workers, but you don't know which of these workers label well and which of these workers label badly. So that leads to a learning problem about how do you infer quality when you don't know the quality of either the evaluators or the items that are being evaluated. There are questions regarding learning content quality and incentives. So if the people who are producing the content have incentives in terms of how much attention they get, whether they produce content or not is going to depend on the learning algorithm you use to determine their quality. Because if you explore a lot, everyone's getting a lot of attention and they have incentives to contribute. So basically what this reduces to is a multi-armed bandit problem, but where the arms of the bandit are produced in response to the incentives created by the algorithm itself. You get questions about, again, rewarding quality when the ground truth is unobservable, and that's what I talked about. That's a problem that arises in crowd work, but also more specifically in peer grading, for example. If you have a whole bunch of students that are peer grading a homework assignment, how do you sort of reward them for doing a good job when you don't know what a good job would have been on that assignment? So this was sort of a case where a bunch of questions really were thinking about incentive design in online contribution environments leads to interesting new theoretical problems. But theory can also inform the design of incentives. And what do I mean by that? So here's one example. So if you think about badges on the web, right? So gamification is something that's become increasingly common on the web. Websites use badges and leaderboards and all these kinds of things to get people all engaged and motivated and so on. And there's empirical and experimental evidence, as well as plenty of anecdotal evidence. There are really websites that discuss, how do you get on the Amazon leaderboard. So there are whole websites devoted to how do you make it to the top 10 in Amazon leaderboards and so on. And these gamification rewards are therefore clearly valued by agents, but you need to put in work to get these rewards. But that means that badges induce mechanisms, right? Essentially, you're in a situation where here is something that users value, these badges, these rewards, and it takes effort to earn them. How do you allocate these rewards to get users to do what you want? So the design of badges affects the participation and effort that you, at least it should affect the participation and effort that you get from users. And if you think about it, there's a whole bunch of different badge designs online. There are badges for meeting absolute milestones, like answering a certain number of questions or getting a certain reputation or so on. And there are badges for being better than other contributors. So for example, competitive top contributor badges, like Yahoo Answers has badges for the best few contributors and so on. There's also issues about information about winners. Do you make it public how many people have a certain badge, or do you keep that hidden? And you could ask the question, these are very different incentives. Well, they're not different incentives, they're definitely different mechanisms. They're rewarding people for different things. What incentives do these different designs create? So for example, should you have absolute or competitive badges? What are the different incentives created by each of these mechanisms? If you're awarding competitive badges to the best contributors in the population, should you make that a fixed number of badges, or should you make it a fraction of the number of people who contribute? So for example, should you say, I'll give out prizes to the top 1%, or should you say that I'll give out badges to the top 10 people? And if you don't know how many people are going to participate, if that itself is a choice, then these two needn't be the same thing. Should you make winner information visible or not? And what if the value from winning depends on other people's performance? And turns out that a game-theoretic analysis can, at least to the extent that you believe the model the game-theoretic analysis is in, can inform the answers to all of these questions, which are really what you'd think of as design questions otherwise. So this was just meant to be an overview talking about how incentive design for online contribution environments both leads to interesting new theoretical questions as well as can inform the design of these environments. But when you think about what we talked about here, which is to say that formal analysis can provide input to the design of online environments, anytime you're talking about incentive design, for incentive design to be effective, what you really need is an accurate model of agents. And there's a growing family of work, both empirical and experimental research on online crowdsourcing platforms like Mechanical Turk and so on, as well as a stream of literature just straight out of behavioral economics, which suggests that real users may not behave like standard economic agents. And if you aren't very familiar with what I mean by standard economic agents, I don't mean one single thing. There are some very classic kinds of models that are used in economics and that could potentially be applied to these settings we're talking about, except you could ask the question, do they really apply? And that's something that really needs to be thought about if you want this work to have any kind of real impact. And that's something I got really curious about sometime a year or so ago, which is with all this literature which talks about how users online are behaving weirdly or non-typically in some sense. There's this whole stream of experimental work, and then there's this whole other stream of theory work which is not really talking to this work. What happens if you really start looking at this experimental work and asking how does that influence theory? Does it have an impact at all or does it not? So the question I got really curious about is, what does this mean for analytical design? Does it at all lead to interesting problems? Does it at all lead to different designs? Does it lead to exactly the same conclusions? Is this interesting or is it not? And you could, of course, ask this question. I'm going to talk about it in a specific setting. But I just want to point out, before we go on to the specific setting, that this is a very broad question that you can ask in a whole range of contribution settings. That you can ask in a whole range of settings, in fact, not just contribution settings. You can ask it in the context of matching markets, for example. You can ask it in the context of voting and so on and so forth. I'm going to talk about this specifically in the context of design for contests or competitive environments. And what I'm going to talk about here is joint work with my colleague at Cornell, Bobby Kleinberg, and this is from this year's EC 2014. So contests where a bunch of agents are competing for some prize or set of prizes are everywhere. There's, of course, contests on the web, which is where our initial motivation came from. There's explicit contests like Quirky or 99 Designs, or the National Geographic. So here is the National Geographic Traveler Photo Contest. So it's really asking users all over the web to submit their travel photos and giving out prizes for that. There's also, in addition to these explicit contests which call themselves contests, there's also implicit contests. So there's contests for attention and virtual rewards and so on. So for example, here is the Amazon leaderboard. And this, really speaking, is a contest after all, right? Users are competing to sort of make it to top spots on the leaderboard. So that's another virtual contest. It doesn't call itself a contest, but it really is a contest. And of course, there's contests not on the web as well. And these contests have been around for way, way, way longer than contests on the web. There's contests for athletics, contests for art, contests for math, like the Putnam Prize. There's contests for research and development. When we all write grant proposals, for example, we are participating in contests and so on. There's contests for design and so on and so forth. So contests are pretty much everywhere. They've been used for a very long time. And since they've been used for a very long time, it shouldn't be terribly surprising that there's actually a pretty large literature on contest design, especially in the economics literature, but more recently in the CS economics literature. And the basic question that this contest design literature goes at is the following. So let's imagine I have $500. So let's imagine I'm National Geographic Traveler and I have, the real estate I have is my web page. And I can show pictures, winning pictures on that web page. The question that this literature asks is, let's say I'm running a contest for innovation, and that's what this literature is really focused on, looking at things like scientific innovation and so on. how do I allocate rewards? How do I design my price structure so as to get the most effort out of contestants? How do I get contestants to try their hardest? So for example, do I give out just one top prize? Do I have a first prize, a second prize, and a third prize, and so on and so forth? What structure really incentivizes the highest effort? And actually, this is a question that was first posed by Francis Galton way back in 1907, more than a century ago. And it took a very long time. He posed this question very informally in this, suppose I had a certain pot of prize money for a race. How should I give away the prizes so as to get contestants to run the hardest? Roughly speaking, this is the kind of question he was posing. And it was only in 1991 that Moldovanu and Sela wrote this now very, very, very highly cited paper on contest design, presenting a formal model for this question and then answering this question in terms of what is a structure. And since then, there's been a huge family of work looking at all kinds of different constraints, rewards, models for how participants behave, what their outputs depend on, and so on. Okay, so if there's this tremendous literature on contest design, why don't we sort of all skip out of here 25 minutes early and finish? It's not just because I like to talk, it's because of this. It's because of the to incentivize effort part. So most of the literature, in fact, pretty much all of the literature, to the best of my knowledge, on contest design talks about allocating rewards among strategic contestants to get them to put in high effort, which in turn determines the quality of their submission, which in turn determines what the contest designer gets. Okay? But if you think about it, there is a huge spectrum of contests also where agents don't strategize about the quality of their submission. Of course, there's a huge spectrum of contests where agents do strategize about their quality. How hard do I need to work to win this prize? But there is also a huge spectrum of contests where agents don't strategize about quality. These come in at least three varieties. So for example, you can think about situations where producing an entry for the contest is really effectively costless to you. It's only the submission that's costly. So for example, think about that National Geographic Photo Traveler contest. You're not going to make that trip down to Zimbabwe to shoot a photo for that contest. You're going to make the trip to wherever you're going to make the trip anyway. And you're just going to make a choice about whether it's worth your while to submit the best picture you have for the contest or not, right? Because presumably submitting a picture takes you some effort. Are you going to bother with that effort or are you not? It's not like you needed to produce an entry for the contest. You already had it. You were going to decide whether you're going to enter or not. Another category is where you actually do need to put in effort to produce an entry for the contest. But the cost that you put in has nothing to do with the quality of the entry that you produce. So for example, if you think about expertise-based question answer forums, like legal forums or health forums, the cost that I incur to produce an answer is the cost of logging in and writing down my answer. And if I am someone who knows a lot about a particular topic versus I'm someone who doesn't know much about the topic, the cost of logging in and writing down what I know is not really different. But the quality of what I produce depends on my expertise, and that has very little to do with my cost. Okay? So that's another kind of situation where you do have to explicitly produce an entry for the contest, but the cost of producing that entry doesn't have much to do with its quality. Okay? And finally, there are best effort environments where indeed it takes you work to produce something for the contest. And indeed, the harder you work, the better the entry that you produce. But where you have some kind of intrinsic motivation for the task at hand, where if you're in, you're all in. So for example, if you really like what you do, if you're a ballerina that dances, for example, or if you're someone who's creating a design because you like it, if you decide to participate, or even if you think about writing research papers for conferences, right? Presumably, we don't say to get a paper into the second tier conference, I only need to work this hard. Therefore, I will write a paper that is X lousy. That's not what really happens. You write the best paper you can and you submit it to wherever. You make a choice about where to submit it, but you don't really make a choice about how hard to work at it, one hopes. So in all of these situations where there's some intrinsic motivation for the task at hand, arts, design, and so on, you really don't strategize over your quality. And you could argue that I'm making it up about the arts and the design, but there's actually real research showing that in user-generated content settings, users do respond to incentives in terms of whether they do contribute something or not, but conditional on participating, conditional on deciding to contribute an answer, the quality of the answer doesn't change with the price that's offered. And this is a very nice field experiment on Google Answers from Michigan again. So clearly there's a whole bunch of settings where users do reason strategically about whether it's worth their while to participate or not in a system. But what they do when they enter that system, what they contribute in the contest, is not something they game once they decide they're going to participate in the contest. And more broadly, we think of this as simple agents. So simple agents are agents who make participation-only choices in systems. They strategically reason about whether it's worth their while to participate. Is it worth your while to become a member of this site and contribute? Is it worth your while to participate in this contest? Is it worth your while to try to send a paper into this conference, or is it not? But conditional on deciding to participate, you don't strategize about what input you're going to provide to the system. And what happens when you think about systems like this is that the economic or mechanism design problem, the game-theoretic problem, really changes very strongly in its nature. What happens is that the design problem becomes a problem of who rather than what. Rather than trying to get the most out of the users who you're assuming are participating, you're really trying to design incentives so that the right people choose to participate in the first place. Okay? And there is, of course, this idea of participation-only choices has appeared before, and this broad idea again of real versus ideal is, of course, something not surprising that's appeared before. I'm going to talk about it specifically in this setting. But I do think that this idea of simple agents is something that may be relevant quite broadly in a variety of low-cost contribution environments, where people are not really talking about huge cost-benefit analysis like in auction design theory, but where they're talking about really small costs and benefits. And this is something that experimental work needs to verify. So what we're talking about here is contest. So let's think about the contest design problem for simple agents. So think about contest environments where potential contestants strategize about participation, but don't strategize over quality. What do optimal contests for simple agents look like? And now to make any sense of this question, I need to introduce for the first time a little bit of math. So the setup is the following, and there isn't going to be much of this because I'm told we need to finish in about 50 minutes, so I'm not going to subject everyone to too much of this. Think about a setting where there's n potential contestants. Each of you is someone who is making a decision about whether you're going to participate in that crowdsourcing contest like Kaggle or not. Each of you has a type which is two-dimensional. You're described by two numbers. The first number is how good an entry you're going to produce if you participate. And the second is how much pain how do you incur to make this contribution, okay? And these numbers come from some distribution, okay? And this distribution is known to everybody and so on and so forth. So you either produce this quality, this fixed exogenous quality at this cost Ci, or you're out. You're not in this contest at all, and this differs from the standard contest design models in that there isn't an effort choice. The standard contest design model would say, you produce something in an interval, let's call it 0, 1, incurring a cost which is a function of what you produce. That's what the standard contest design problem would say. We're saying instead that you produce either at one endpoint of the interval or at the other endpoint, which is 0. And each of those has a particular cost benefit associated with it. If you produce nothing, you incur no cost. If you participate, you produce a certain quality and incur a certain cost. And now what happens is that my strategy in this game, and I'll say in a moment why this is a game. My strategy in this game is very simple. Do I participate or do I not participate? I will say in a moment why this is a game after I tell you what a contest is. A contest is a monotone non-negative rank order mechanism. What does that gobbledygook mean? It means that the contest designer observes the ordering of the outputs that everyone produces, and he can rank them. He may not be able to measure them numerically, but he can rank them. And he can give out prizes based on rank. So for example, the person who finishes first in the race gets a certain prize, the person who finishes second in the race gets a certain other prize, and so on. It doesn't depend how fast you finish the race, it just depends that you finish ahead of everyone else, okay? Now why is this whole setup a game? It's a game because, think about me. I'm trying to decide whether to participate or not. How do I decide that? Am I going to get non-negative utility out of participation or not? How do I decide that? I know that if I participate, I incur a cost of CI, but what's my benefit? My benefit depends on which prize I win. To make it simple, just to understand why it's a game, let's imagine there's just one prize. So imagine there's this $500 prize sitting here, and it costs me, let's say, $100 worth of effort to participate. Whether I get that $500 or not depends on whether someone better than me decided to participate or not. What is the probability that someone better than me decides to participate? Hey, it depends on how they are deciding whether to participate or not. So my payoff depends on other people's choices. And so all of us have to reason simultaneously and arrive at some kind of equilibrium about all of our participation decisions, such that none of us is unhappy with our participation decision given everyone else's participation decisions. Is it clear why this is a game? Okay, good. So now we have a contest, and the mechanism designer's question is, do I give away one prize of $500, or do I split it up as, let's say, 300, 200, or do I give away 100 prizes of $5 each, and so on and so forth? And these are all things that the mechanism designer could do. How the mechanism designer splits up prizes determines how each of us decide whether or not to participate, and that determines in turn the quality of submissions that the mechanism designer is going to get. So we are interested in asking, of all the possible ways that the mechanism designer could split some total prize, and this could be the total real estate on the National Geographic webpage. Do I just display the 2 best photographs all the time and give them all the attention? Do I rotate amongst 12 photographs in order? Do I split up my $500 across the top 3 contestants or across the top 10 or one winner take all prize? How do I do this in a way that maximizes my objective? And this could be either to get the best possible single submission, or it could be to get a whole pool of good submissions. The top 12 submissions, I want them to be really good or something. Okay? So this is the nature of the problem we're talking about. Now, to keep things at a high level, I want to sort of address this question, why would the contest design problem, which has been studied so extensively for effort choices, where you choose your effort in an interval and your cost depends on the effort you choose, be different when you have simple agents? Because after all, participation only choices are a subcase of strategic effort choices, where instead of choosing points through an interval, you're choosing at one endpoint of the interval or the other. The reason the incentive analysis and design change is because competitors don't really adjust their effort in response to other people's choices. If you're in, you're all in. If you're out, you're all out. And that changes the nature of the best response very much. The other reason is that unlike in the standard contest design model, agents are really described by a one-dimensional type. Here, there are two-dimensional types, right? I'm described by 2 numbers. Yes, Dan?
I'm sorry, I missed. What do the agents know about how many people are participating?
So they know the number of potential contestants as well as the distribution from which everyone's qualities are drawn. So that's assumed to be common knowledge. And of course, you could ask what happens if that's not known and so on and so forth. We're not doing that here.
And they know the vector rewards, V1 through Q.
Yes, yes. So that's public information. The mechanism designer announces the contest in advance, and specifically one subtlety that you don't redistribute any leftover money. So it's announced in advance. So these are really the 2 reasons. One is that you don't adjust your effort continuously in response to what others are doing. You have to go either all in or all out, and that introduces a kind of discontinuity. And the other is this 2-dimensional mechanism design in general is very much more complicated than mechanism design when agents have just one-dimensional types. And I just want to draw an analogy here between continuous versus discrete optimization. So when you have continuous optimization, you're really asking about agents, who are solving, let's say, you're choosing variables over a continuous interval. And when you go from continuous to discrete optimizations, things really change dramatically. It's not as simple as saying, oh, you're just choosing one endpoint or the other of an interval, so things should be this simple. There's the whole literature on, hardness and so on that comes about when you change from the endpoint, from a whole interval to the endpoints of an interval. So in some sense, ex post, as in when we started doing this, we were like, why should this be different? And when it turned out to be really very different technically, we were like, oh, I see. It makes sense that it's different after all. This is, the analogous version in optimization, when you don't think about strategic behavior at all, did turn out to be very different. So simple agents, it's not surprising that simple agents are quite different from strategic agents. So the main results look as follows. So let's imagine a situation where the cost of submission is approximately the same to everyone. This could be, for example, when the cost is primarily of submission. You have to pay an entry fee, or you have to incur some kind of time cost. In this situation, it turns out that optimal contests are actually simple, which is to say that they award equal prizes to all winners. So you would never have an optimal contest that looks like 300, 200, 100. You should be awarding an equal number of prizes if this is how agents behave and if you have homogeneous costs. And this is quite different than what you get when you have strategic effort choices, because it turns out that you either always have a winner-take-all prize or a number of unequal prizes depending on the shape of the cost function. When you have heterogeneous costs, things turn out to theoretically be actually rather interesting. At this point, Anna.
Yeah. You mean that if there are a different number of contestants, then their prize will be different?
Yes.
It's just V over the number of actual people who participate.
No, that's not the optimal price. The optimal price, actually, let me quickly show you. So this is what the theorem looks like. You award prizes J star prizes of size V over J star, and all of this comes from an LP. And J star is something we can actually say things about. It turns out to be extremely complicated to say things about J star, but even getting the structure that you have equal prizes is quite unusual and not common. So it's very much to do with, I think, the simple agent structure that leads to this prizes. When you have heterogeneous costs, it turns out that the standard method for solving contest design problems, which has been used in this whole humongous literature, is to say, I will solve for the equilibrium of an arbitrary contest, and then I will ask what is the contest that has the best equilibrium. And this technique simply does not work, because when you have these two-dimensional mechanism design problems, you cannot get any handle on equilibria. So we essentially had to do something completely different and define a new notion of sub-equilibria to work our way around the fact that we couldn't access equilibria at all. I'm not going to go into details about this at all, except to say that these results do have implications for design. So for example, when you have competitive environments with homogeneous costs, of course, it says that you should have equal prizes instead of first, second, third positions. More interestingly, it says, for example, that you should perhaps have badges instead of leaderboards. So leaderboards essentially give rise to unequal rewards to different positions, whereas an identical badge handed out to all top contributors is essentially an equal prize. So the right number of top contributor badges, if costs are homogeneous and you have simple agents, should do better than a leaderboard. Okay? And this is, again, badges or leaderboards is something you'd think of as a design question. And it's interesting that a formal analysis can actually help you understand what you need to understand about your environment of users and their costs to decide which way to go. I'm not saying it answers the question conclusively. I'm saying it suggests what you need to understand about your population, about your site, before you can make a decision like this. There's also another kind of design implication. So for example, if you are someone who owns a website where tasks are perceived as equally costly by all users, it turns out from the equilibrium analysis that pretty much every objective is maximized by the exact same contest. Which contest, of course, differs depending on the parameters, but you don't have to choose between objectives. So for instance, if your objective was the max objective, corresponding to quote-unquote getting excellent content, versus if your objective was build a community, get a large number of contributions, you don't have to make a choice. On the other hand, if you're in a heterogeneous cost environment, it turns out that these objectives are not maximized by the same structure. So this would suggest, for example, that as a site designer, you now need to make a choice about whether you want to build a community or get some excellent content. And what you do, the reward structures you'd put into place would be different in both cases. And again, this kind of formal analysis could help inform which way you go. So there's a lot of stuff we don't understand about simple agents in the context of contests specifically, but I'm going to leave that aside for now. I just want to add in terms of simple agents that this idea of agents who make choices only about participation, who are simple in that they're not idiots. They do think about whether it's worth their while to do something or not. But having made that decision, they're not really trying to game the system. I think this idea of simple agents is potentially something that's relevant in a lot of settings, because in a lot of settings, I think you would find users reasoning about whether it's worth their while to do something, but not exactly about what exactly they would do. So just want to mention this about simple agents, and now I want to sort of move on to the conclusion, talking about where we are and what's next. And I didn't get to tell you in great detail about all of this, but I think I just provided you with an overview saying that, where are we right now? There is a growing set of papers that talk about an analytical framework for online contribution environments. There are abstract models that help you get insights in terms of what could help in certain environments. For example, the glass door type of mechanism versus making quality a prominent feature in how you order things where you have attention rewards. And there's stuff in the context of explicit contribution as well as in the implicit contribution area. And this is something we didn't talk about at all, but is also getting to be a fairly popular area of research. One area that really hasn't been looked at much at all, if you think about it, you can think about explicit contribution as environments with effort costs, where what's really costly is for me to produce the contribution. And you can think about this implicit contribution environments with private data as environments with privacy costs. And really, there hasn't been any work that I know of that looks at environments which have both effort and privacy costs. And effort could mean participation as well as, actually how much do you decide to work, as well as whether you decide to do something at all or not. And you might ask, why would anyone bother to think about that? And I promise you I'm not making this up. This is actually for real. How many of you are familiar at all with Foursquare? Okay, a fair population. So you probably know that Foursquare is a social apps to discover new places, huge user base, huge number of merchants that discovered this. And this whole economics of online contribution that I talked about, it's really all happening on Foursquare. So Foursquare does use badges to incentivize users to check in. It awards them it awards them badges for all kinds of things. Things like, you checked in at a certain place a certain number of times, you check in so many days in a row, and so on and so forth. And notice that here there's a privacy cost. Of course, there's an effort cost to checking in, to making the choice to check in. But there's also privacy cost, because the more you check in, the more Foursquare and whoever they're selling your data to knows about you and what you've been up to. So there is a greater privacy cost as well, and it's not clear how salient this is to users. And there clearly is value from contribution, because there's this very recent news article, just June 2014, talking about how Foursquare is about to start charging merchant fees and selling data to users, and so on. So these contributions do have value. And here you could ask questions about design and policy as well. Is it right for Foursquare to be selling users' data? What does it even mean to ask the question, is it right? How should property rights be assigned in this kind of environment? Will Foursquare even find it worthwhile to provide services if it cannot do what it's doing with your data? So there's a whole range of policy questions that sort of interface with economic analysis over here. So these environments with effort and privacy costs are real and they're relevant. But I think anytime you think about online contribution environments, it's very important to think about this idea of behavioral design. Thinking about designing optimal environments for real users. And I think what we discovered when we worked on this contest paper is that how users behave can really have implications for design in terms of how you design environments. So whether users are strategizing over effort or not does make a difference to how you should be designing the environment, because the optimal contest does look different depending on whether users are only making participation choices or whether they're making effort choices. And so I really like to think about this as behavioral design, which is sort of an interconnected family of research questions. First of all, how do users really behave? And there's a whole bunch of work that's already begun, very interesting work on how users behave regards privacy, crowd work, as well as rating online content. And there's a bunch of very interesting questions, of course, regarding theory, economics, algorithms, and learning. The whole idea is look at these papers that talk about how users really behave and incorporate those papers into the models that you use for agents when you talk about a mechanism design problem. And I think that for any kind of theoretical design to really be effective, it really needs to take input from all of this experimental and empirical work. And of course, it can inform the experimental and empirical work in return by asking what are the questions you need to understand about your population. And that brings us really to my conclusion, which is that there's really a huge room for crosstalk over here between theory, data mining, HCI design, and policy. The theory and experimental empirical research, like I said before, it's not really new. It's something everyone should be thinking about. The economic analysis policy one is not really that new in the econ field, at least, except it's not really been thought about much in these online environments at all. How does policy and regulation influence what you get by way of online contribution, especially in the context of privacy and markets for data? And finally, I think there's room for a really nice give and take between game theory and interface design, because the interface really defines the game. What do I mean by that? What are the space of available inputs to the mechanism? So for example, do you get ratings on a scale of 1 to 5, or do you get ratings on a scale of 1 to 2? It really defines the space of inputs that are available to either a mechanism or even a learning algorithm for that matter, right? What do you learn on? You learn based on the interface that's put in place by the interface designers. It defines the space of available rewards. So if you think about it, YouTube videos have this thumbs up button and they clearly specify the number of views. That is an interface design choice, but it defines the fact that there is an attention reward available on YouTube. If YouTube's interface did not put in the number of views and the number of thumbs up, there would not be this reward that's available that people are working for. So the design of the interface really even defines the game to the extent of saying which are the rewards that are even available in this game. And finally, there's this idea of information as a design choice. What do agents know about the environment, other agents? How well are other agents doing? What are other agents doing? And these are very essential components to any game theoretic or formal analysis. So, and this again is determined by the interface design. So there's really a very tight connection between any kind of game theoretic or formal analysis and the interface design. And I think there really is huge room for crosstalk here for interface design folks to get together with theory folks, because what interface you put in defines what game is being played. But what game is being played in turn determines how well the system does. And these two really need to talk to each other to sort of get the best outcome you can out of the whole system as a whole. So finally, I want to conclude with this idea that formal analysis has a huge give and take with the design of these online contribution environments, with data mining, with HCI design, and with policy. And with that, I want to finish with this slide from XKCD. Thank you.